Human in the loop is a crucial component for agentic systems, but how can we implement it for REST APIs where the request response model does not allow for long running workflows? Let's say that we have a run workflow endpoint that runs a LlamaIndex workflow. And inside that workflow, we have a step that requires user's confirmation. And as this is a REST API, as soon as we respond to the request asking the user for confirmation, the current unfinished workflow is going to be terminated early and we will lose all the progress so far. Instead, before responding, we can take a snapshot of the current state of the workflow using context.toDict method alongside a serializer, for example, the JSON serializer. And after serializing, we save the state in a database, for example, MongoDB. And finally, we cancel the workflow execution so far and return an API response asking the user for confirmation. And now the client can send another request to the confirm action endpoint by either accepting or rejecting the action. After receiving the request on the server, the first thing we do is to retrieve the saved state of the workflow from the database. We pass that retrieved state to the context.fromDict function, and we sort of resume the workflow execution from where we left off, skipping all the previous steps. And finally, after executing the rest of the workflow, it returns the API response to the client with the output of the workflow. Now let's look at the code. First, we need a task that requires user's confirmation. In our case, this complete payment function is going to simulate that. Now let's create the workflow. We're going to call it the payment workflow, and it has two steps. The first step is the start step. It takes the user's message from the input first, then it uses the LLM's chat with tools function, passing in our complete payment function as a tool, and also the user message. If there's no tool call involved, then we just return the string response in the stop event. But if it decides to use the payment tool, then we just return the confirmation required event. If that event is triggered, then we run the next step, which is the confirmation step. This is the step where we wait for the human confirmation. And we do that by calling the context.waitForEvent method. The first argument that it takes is the event that it's waiting for. In our case, it's waiting for the payment confirmation event. So the workflow is going to be paused at this statement until the payment confirmation event is triggered. And we also have a second argument, which is the waiter event. And we set the waiter event to be this waiting for user confirmation event. We also pass in a message for the user. So what the waiter event does is while we're waiting for the payment confirmation event, it sends this waiter event, which is waiting for user confirmation event, to the event queue. It tells the user that the workflow is currently paused and waiting for payment confirmation event. So after waiting, when the payment confirmation event is triggered and the user accepted the action, we perform the payment and set the final output to be payment completed successfully. Otherwise, we set the final output to be payment aborted. So that's the workflow. And now let's look at the API handlers. The first endpoint is the run workflow endpoint. From the request body, we get the input for the workflow. Next, we create the workflow instance and run the workflow, passing in the input. We await the workflow handler to get the final response. And finally, we return the response with the status set to done, and we put the workflow output as the response body. This is the case where the workflow does not require any user's confirmation. We check that by iterating over all the emitted events. And if the instance of the event is waiting for user confirmation, and from our workflow, we know that this event is the waiter event for payment confirmation event. So by receiving this event, we know that the workflow is currently waiting for user's confirmation. So in that case, what we do is we get the context from the handler and we take a snapshot of the current state of the workflow using context.toDict function, passing in the JSON serialize. And after saving the state of the workflow, we can cancel the workflow execution using handler.cancelRun. And for demonstration, we store the workflow context in memory. But for production, we're going to be using a database like MongoDB. And we also use a confirmation ID so the user knows which workflow to send the confirmation to. And after that, we finally return the API response. We set the status to confirmation needed. And inside the body, we also return the confirmation ID and the message from the waiter event, which is this message right here. Now let's create the next endpoint, which is the confirm action endpoint. First, we get the confirmation ID and the user's confirmation whether the user accepted or rejected the action from the request body. We also check whether the confirmation ID is not in our database. In that case, we just return an error response. Otherwise, if the confirmation ID is in our database, then we retrieve the workflow context from the database. And we use context.fromDict method, passing in the workflow and the saved state to create the resumed context. And from the last endpoint, we know that the last time this workflow has run, it was waiting for this event, the payment confirmation event. So what we do in this endpoint is we send the payment confirmation event, passing in the user's confirmation. And now we call workflow.run method, but we pass in the resumed context. In this case, it's going to skip all the previous steps that is already done, and it's going to resume from this payment confirmation event. And finally, we just capture the final output from the stop event, wait for the rest of the workflow to be completed, and return the final output. Now let's look at the demo. First, for the run workflow endpoint, we ask the agent to complete payment for me. And if we run this, we can see that in the logs, it's inside the star step. So it's in here. Also, we can see that waiting for user confirmation event has been triggered. And the response that it has returned, the status is confirmation needed, and also the ID for the confirmation. Now we copy that ID and go to the next endpoint, which is the confirm action endpoint. And we use that ID and accept the action. And if we execute that, we can see that the returned message is payment completed successfully. And if you look at the logs, we can see that it says inside confirmation step. So it skipped the start step and started from the confirmation step, which is exactly what we want. So that's how we implement human in the loop in REST APIs using LlamaIndex workflow. In the next tutorial, we're going to see how we can implement human in the loop in WebSocket. I hope you enjoyed the tutorial. Thanks for watching.